Hello, everyone. So today we'll be presenting our entity relationship diagram for a Spotify-style music streaming app. Now, our ERD represents the structure of a Spotify-style music streaming application. It captures how users, songs, playlists, artists, albums, genres, and playback histories are connected. Now, let's go through the tables one by one and focus on their relationships.
We start with the user table. A user has a unique ID, username, and email. One user can create many playlists, but each playlist belongs to exactly one user. This makes the relationship between user and playlist one to many relationship. In the same way, one user can also generate many playback history records, but each playback record belongs to only one user. This makes user to playback history another one to many relationship.
Now let's move on to the playlist table. The playlist table stores playlist details such as its ID, name, and creation date. Each playlist is tied to a single user. Playlists are also linked to songs, but since playlists can have many songs and each song can appear in many playlists, this relationship is many to many. To handle this, we introduce the playlist song table, which acts as a bridge between the playlist and song table. Now, Lance will now discuss the next table.
Moving on to the central of our ERD, the song table. Each song has an ID, title, duration, and it's linked to both an artist and an album. The relationship between artist and song is one-to-many relationship, meaning one artist can create many songs, but each song is tied to only one artist. Similarly, the relationship within album and song is one-to-many, meaning one album can include multiple songs but a song belongs to only one album. Songs are also linked to playlists through the playlist song table, forming a many-to-many relationship with playlists. Additionally, songs are connected to genres through another many-to-many relationship managed by the song genre table. Finally, songs are tied to playback history, where one song can appear in the history of many users, making the relationship between song and playback history a one-to-many relationship.
The artist table stores details of musicians or bands. As mentioned, an artist can have multiple songs but each song belongs to only one artist, creating a one-to-many relationship. Next, the album table. It stores album IDs and names. We can see here that the relationship between albums and songs is one to many, meaning an album can contain multiple songs but a song belongs to only one album. The genre table stores categories of music such as pop, rock, or jazz. Now, a song can belong to many genres, and a genre can contain many songs, which makes this a many to many relationship. This handled by the song genre table, which links song and genre without duplicating data.
The playback history table records user activity. Each record contains the user ID, song ID, the stream date, and whether the song was liked. The relationships here are straightforward, where one user can have many playback records and one song can appear in many playback records, meaning both of these are one-to-many relationships.
When taken together, all of these relationships model the way a real music streaming platform works. User create playlists. Playlists connect to songs. Songs belong to artists and albums. Songs are classified into genres and user activity is tracked through playback history. The design ensures data is connected correctly, avoids duplication, and provides the flexibility needed for a Spotify-style music streaming platform application.
To conclude, our entity relationship diagram shows how all the entities in our Spotify-style music streaming app are connected. from users, songs, and artists to playlists, albums, and genres. This ERD serves as the blueprint of our database, ensuring that the structure is organized and relationships are clearly defined. That's the end of our Deliverable 3 presentation. Thank you for watching and see you on the next Deliverable.